Hi guys, welcome to what quite possibly might be the final video that you look at if you're doing stage 2 chemistry. So by this stage now you've probably gone through all the course content and you're just getting ready for your end of year exam. So I just want to go through with you some of the hints and tips and advice for doing the Year 12 chemistry exam, common things I found, mistakes that students make, things like that, just from my experience over the years of students doing the exam. So the first thing I want to help you out with is to understand the different types of exam questions and what you actually need to do to answer them. So look for the different keywords. So they might talk about asking you to describe or suggest and discuss, explain, state, name, identify, or use. So each of those has a different meaning and the examiners are looking for a different answer or variation of the answer depending upon what keyword they're using. So first I'm going to look at is describe. So I'm going to just pull up some examples of previous exam questions here. So we've got a flowchart here. It says describe one method of reducing emissions of nitrogen oxides from the absorption tower. So we've got over here the absorption tower giving off oxides of nitrogen. So it says describe. Now you notice this is 2 marks. So describe one method. So you need to, I guess, sort of state how they would do it. All right, so reducing the oxides of nitrogen. So they might introduce, for example, a catalytic converter, which would convert the oxides of nitrogen back into nitrogen. Okay, so you need to actually describe one, not just state using a catalytic converter, but then describe what it would do. Well, here's another one. One disadvantage of growing sugarcane plants to produce ethanol is that large areas of farming land are used. Describe one possible consequence to society of using large areas of farming land for this purpose. Well, the fact the consequence is that its land is not available for food production, okay, and so the consequence of that is that we could have possible food shortages. So that's where you get your 2 marks from. And it's not just stating it, and I'll get to stating in a minute, but you actually have to describe it. So it's really important that you look at the number of marks, okay, and because there's only one thing here, you need to give an explanation for or describe the consequence, what they're asking for. When they're using suggest or discuss, this is normally more of a 1 mark thing. So here we've got suggest one reason why the actual concentration of hypochlorite ions in bottles of household bleach is often higher than the concentration stated on their labels. So 1 mark here. So you could say something like, so that there's no issues with the concentration in the bottle being lower than what's stated, so they're not open to any lawsuits. So it's just a statement, one sentence, 1 mark. Here suggests a reason why the calculated value was lower than the true value of 726 kilojoules. You could say something like because there's heat loss to the surroundings, and that would be fine because there's just 1 mark for it. You just have to suggest a reason. So keep it short and simple. Don't spend extra time in the exam when you don't need to. In terms of explain is where, again, it's a little bit like where you went back to the first one of describe, but this one's explain in terms of collisions between reactant particles, why an increase in surface area should be a space, produces an increase in the rate of reaction. So an increase in surface area produces an increase in the rate of reaction. All right, so you've got particles that are, you have more particles, so you have more successful collisions per unit time, which leads to an increase in the frequency of successful collisions. So there's 2 key points there, you've explained it clearly, okay? Increased number of particles per unit area, so increased frequency of successful collisions or increasing number of collisions per unit time, they mean the same thing. So there's your 2 marks. Or explain with the aid of an equation how CO2, and that should be subscript again, sorry, dissolved in seawater decreases the pH of the seawater. So this time's with the aid of an equation. So you're going to get 1 mark for having an equation in here. So CO2 plus H2O forms H2CO3. That could be your equation to show carbonic acid formation. Or you could do the dissociation of carbonic acid, H2CO3, forming CO3 2 minus plus 2H plus to talk about hydronium ion concentration production. So that would be your 1 mark for the equation, right? And then you can explain it. So you could say carbon dioxide dissolves in the water to produce carbonic acid. All right, that dissociates in water to produce hydronium ions. Those hydronium ions help lower the pH of the water. Now, what's important to understand in a question like this, it says explain with the aid of an equation. So if you explain something and put an equation in, so if you say carbon dioxide dissolves in water to produce carbonic acid, and then you give the equation for that, and then you say this lowers the pH of the water, you're not going to get your 3 marks for that because you've explained the equation, they're the same thing. So you need to have carbon dioxide dissolves in water to produce carbonic acid. then you could say carbonic acid dissociates in water to produce hydronium ions. All right, so there's your second one. You can then give the equation for that, and then you can talk about the fact that that lowers the pH of water. So be specific. Don't explain your equation because it's the same thing. Okay. State or name, these are normally really straightforward. So state why CO is considered to be a pollutant, okay, because it causes respiratory irritation or it's harmful to human health. You just state it, bang, 1 mark, done. State and explain, so they're actually bringing in 2 parts here. So state and explain whether CO is a primary or secondary pollutant. So you're going to get 1 mark for stating if it's primary or secondary. So anytime you get these sorts of questions, just have a guess if you need to. You've got a 50-50 chance of getting it right in this case. But carbon monoxide is a primary pollutant, and then you give your explanation because it is emitted directly into the atmosphere. Okay, so there's your state and explain, combining them together now. Or name the new functional group that is formed when lactic acid monomers react to produce polylactic acid. Okay, or you're producing polymer from lactic acid, so you're going to be producing an ester. So name the new functional group is ester. Now, notice it says name there. So in this case, you actually have to write ester, E-S-T-E-R. You can't draw the C-double-O-O, anything like that, because it's asking you to name it. So make sure you read the question carefully. State and explain, I've already given an example of one of these. So at 25 degrees, the equilibrium constant is 8.3. State and explain whether the forward reaction is exothermic or endothermic. So at a Kc of 8.3, we don't know the equation for this, but that shows a lot of products. At 25 degrees, and then you need to know the rest of it. So it's, without the rest of the question, you don't know really which one it is, but you would say in this one, for example, it's exothermic because a increase in temperature, I have to think this through in my head, sorry. So an increase in temperature favors the endothermic reaction. All right, so the Kc value would have gone up if the temperature was increased, and so you're stating and explaining it. Okay, just doing that off the top of my head, so I hope I got that right. Please feel free to comment below if I made a mistake. In the second one, if water could be removed during reflux, state and explain how this would affect the percentage yield of the ester. So state the percentage yield of the ester would increase, 1 mark. Explain why. The equilibrium would shift to the right according to Le Chatelier's principle to replace the water that is lost and counteract the removal of it. Okay, so that's your explanation, 2 marks. Stating is 1 mark. Hence state. So this is where you're using part of the question or the answer you've done before. So here we've got an example of a battery. All right, we've got a general metal here with nickel hydroxide. We've got the charging process and discharging process. On the equation above, assign oxidation states to nickel. All right, so up here the nickel has a 2+ oxidation state. Up here it's got a 3+ oxidation state. So hence state whether nickel is being oxidized or reduced. So you need to have a look at you going from +2 to +3. Increase in oxidation number is oxidation. All right, so you hence state you're using the information you've used before. Okay, the other way you could tell this one's being oxidized is because you're gaining extra oxygen in there, but you have to use the information from the previous question. Identify is pretty straightforward. You have to use the graph or an equation. So this one, identify the group of organic molecules to which cysteine and serine belong. Well, both of these are amino acids because they've both got this carboxyl and amine group on it with a central carbon atom, okay, with a hydrogen on it. And here's your side chain for cysteine, your side chain for serine. They're both amino acids. You just have to 1 mark, 1 suggestion. Example 2, identify the anode in this battery. Okay, so this is a galvanic cell. In a galvanic cell, the anode is negative. So the positive one here is the carbon electrode. All right, so that's the positive one, that's the cathode. So the zinc electrode around here is the negative one. That would be the anode in this one. So the zinc electrode is the anode. All you got to say. Use. So when they're asking about using, they're talking about getting information out of the question. So during cement production, calcium oxide reacts with silicon dioxide to form a mixture of silicates. Using this information, explain whether silicon dioxide has an acidic or a basic character. All right, well, you've got calcium oxide, which is a metal oxide. Metal oxides are basic, so silicon dioxide is reacting with a base. Okay, so that means that it has an acidic character. So you're using the information up here. The fact that this is reacting with a basic oxide, all right, shows that it has an acidic character. So you need to use what's in the question. This one here, calcium ions and and hydrogen ions. So this is the equation, the equilibrium for in soils when you've got acid rain coming in, for example. So using the Chatelier's principle, explain how the presence of clay reduces the effect of acid rain on river water. Okay, so up here you would say clay, so the presence of clay here. Okay, when there's acid rain, the clay can absorb the hydrogen ions from the water onto the clay. So as the concentration of H plus from acid rain increases, equilibrium shifts to the right to counteract that increase, and so the concentration of the H plus is going to decrease again, and the H plus ions are going to be bound to the surface of the clay. So that you could talk about how the clay particles therefore reduce the amount of H plus that comes from acid rain. Circle is really easy, but it's also one that students tend to get quite wrong. So in here, I'm just going to use this color here. So circle the primary amine group on this structural formula. We've got this one here, which is a secondary, and this one here is a primary. So it's really important that when you're circling, that you actually circle, oh, well, there you go, I'm doing a square on it for that for some reason, okay? But it doesn't really matter. But you see how I'm doing just the circle of that group. It's really important that you don't get sloppy and circle up for bits over here. Okay, so I'll show you what that looks like on the next one. Okay, I'll go to a different color in this one. So down here on the diagram below, circle the feature that allows cross links to form. Well, it's this carbon-carbon double bond here because you're getting cross-linking between the chains. You get addition polymerization occurring. But you're asked to circle. If you circled it like this, for example, okay, you're including other carbon over here, you're kind of going through the carbon over here. It's not clear, you're not being careful. So what you need to make sure that you do is actually circle it properly, okay? So just circle it nice and neatly so that you can actually see that no, it is in fact just this bit here that we're focusing on, all right? Don't lose a mark just for sloppy circling, all right? Really important. Drawing the structures, all right, draw the self-ionized form of serine. So the self-ionized form for serine here will have a hydrogen over here, okay? Really important when you're putting the self-ionized forms that you get the charge in the right space. So the positive is over here on the nitrogen, okay? And then this hydrogen here obviously disappears, so we've just gotten rid of that. And there's a negative charge over here, okay? Now, what's really important is to not have sloppy bonds, okay? So look very clearly here that the carbon is attached to the OH. So what we mean by sloppy bonds is if you're drawing a structure and you've got a carbon here, if you draw something like this, OH, and what you're showing here is you're saying that the carbon is bonding to the hydrogen. That's sloppy bonding. So that could be some point during your exam where you'll lose just one mark just for not being careful with your bonds. So please make sure you actually show where the bonds are going. Make it nice and careful, all right? Make sure your charges are in the right spot. If you want, do it on some scrap paper first. You can do graphs and structures in pencil. So I really recommend that you do that in the exam rather than doing it in pen. Makes it much easier to correct later on. When you write equations, they're generally worth 2 marks. You don't need states unless it's for thermochemical. So the first mark is for the correct species. So having H2CO3, not H2CO4, for example. If you don't get the correct species for the equation, you cannot get any marks for it, okay? Because your second mark comes for it being correctly balanced. All right, so if you get this wrong firstly, all right, you're not then going to have the correct balancing of it either. All right, so it's really important that you know your common things like sodium hydroxide, like sulfuric acid, like hydrochloric acid, like glucose, all right? Sodium hydroxide, learn all of those common formulae so that you can put them into equations, all right? Don't lose any marks for that. When you get to thermochemical equations, you must have the correct species and be balanced, like up here, same as here, but you must also have the correct states at room temperature. So one of the common things that people do, particularly for combustion reactions, is they put water in as a gas. Okay, now it actually exists as a liquid at room temperature, so you must have that in. And you must also have the correct enthalpy and sign. So if it's combustion, it must be negative 1,320 kilojoules, for example. So make sure you put those in for thermochemical equations. When you're drawing your graphs, I always recommend you do pencils. Label the X and Y axis if they haven't already done it for you. and get your scaling correct. So when you've got something like this, what they don't want to see is a graph, for example, that uses just that little bit. Okay, what they want to see is they want you to see you've got a graph which uses the whole section. So count out how many squares you've got firstly, okay, and then get your graph to use the whole space. All right, make sure you put your points on it clearly. All right, if it's data that you can put a line of best fit in, put your line of best fit in as well. Okay, make sure you use exact headings they've got here to put onto your graph. Okay, and make sure you get your dependent independent variables correct. So your independent goes down here. Okay, your dependent variable goes on the y-axis there, and so work out which one goes where and make sure you label it. Okay. When you're using graphs, if the question states to use the graph, make sure you show on the graph how you've used it. So here's an example: a sample of water from a metal pipe has unreacted silver, concentration of 0.4 milligrams per litre. So here's the 0.4 milligrams per litre. All right. Use the information in the graph to determine the acceptable range of absorbance values that would correspond to this concentration. Okay. So you come up here to that value, you come across to here. So sorry, my line's not straight at all, but you're going to get about 0.28 there. Okay. So you're using the graph, and then it says the resolution of the spectrometer is plus or minus 0.05. So you're going to be going between 0.275 and 0.285. So really hard to type with a mouse. All right, so that's your range that you get there, but you're using the graph here. Like you've shown on the graph how you've actually plotted the point in. In your calculations, there will be a section here where credit will be given for the correct use of significant figures in answers to part B. So there'll be one question in the exam for that. Look for where that is. Make sure you give it to the least accurate, okay, of the results that you're given. This bit here, this used to apply. You can actually not worry about this anymore, all right, because now there's only one question in the exam which actually relates to the use of correct significant figures. Other than that, it doesn't matter. Don't go overboard, just try to be sensible, but just look for that one particular question that uses the significant figures. All right, give it to the least accurate. So if you've got three bits of, if you've got three things that are like 20.0, all right, and then you've got another one which gives a reading of like 17.35. Okay. Sorry. All right, that's a 5. Really dodge. This one here is to 4 significant figures. This one is to 3 significant figures. So you'll give your answer to 3 significant figures because that's the least accurate of the glassware or the measuring devices you're using. In your extended responses, you'll normally get 2 of these in the exam. All right, there's normally 6 plus 2 questions, 6 marks for what you write and 2 marks for how you write it. Try to set it out really clearly. So make, if it's 6 marks, and basically you want 3 dot points. So they're kind of like state and explain. State it, explain the reasoning. Then do the next statement, explain it. Okay. If you're using equations, do not balance. You don't have to balance them and waste time on it. You can just put it in. Okay. You don't use dot points though, because they want to see clear and coherent chemistry communication. So don't dot point it, have it in paragraphs. Okay. Best way to do those is just to practice. So selecting an appropriate pressure for this process is an important consideration for manufacturers. Explain 2 advantages to manufacturers of using a high pressure, but suggest why manufacturers may decide to use a moderate pressure instead. Okay. So your 2 advantages are obviously going to relate to the yield and the rate. Okay, so high pressure increases the concentration of all your particles, okay, which leads to an increase in the rate of a reaction. All right, so that's an advantage to the manufacturer because they get their products faster. So there's one paragraph. Second advantage is that in this case for high pressure, Le Chatelier's principle, it favours the side with the least number of gaseous moles, which in this example was the products. So an increased pressure increases the yield of the products, and so that's beneficial for the manufacturer because they will get more of their product. Okay, but that's the second paragraph. Third paragraph, why manufacturers may decide to use a moderate pressure instead. High pressure requires specialized equipment and lots of energy, which can be very expensive. So they may decide to use a moderate pressure instead to still increase the rate and the yield, but not as high a cost. There's your 3 paragraphs. There's your 8 marks. Last thing I haven't put into here, which I probably do need to update because they're new into the exams, is the SHE questions. With the SHE questions, all I've got to say is that you've got to make sure that you link it to one of the SHE capabilities. You've got communication, collaboration, development, influence, application, and limitation. Make sure that you link one of the bits of information in the question to how scientists, all right, are actually maybe collaborating, for example, how they're communicating, how the scientific information is being developed, and how, for example, maybe that other things like maths or engineering are influenced different science endeavours. Or you might want to look at maybe that the application of a device has unknown consequences, so there are limitations to it. So just make sure you know your key concepts, and that you link some of the information in the question, right, to one of the key concepts. Apart from that, I really do wish you all the best. I really hope that you guys go on to some form of chemistry later at university. If this is the last time you do chemistry, then thank you very much for choosing Year 12 chemistry, and I wish you all the best. Thanks, guys.